So, welcome to interaction number 6 for Ce488 Environmental Geotechnics. I will take up the question which has come for discussion. So, the question is that why do not we use old tires as a raw material for other industries or use them in construction? Rahul is here. Oh, a lot has been utilized, a lot. Most of the infrastructure development, if you check on internet and particularly if you go to the construction in earthquake prone areas like Japan, most of the retaining walls have been done out of automobile tires, fine, as such. So, I can send you a link, but you can also find out and post it on the group MS Teams for everybody's sake. So, construction industry can utilize old tires quite a lot and without processing it, fine. Number 2 is any other industry where you think that tires can be utilized, Professor Prathan Singh? Yeah, so Prathan Singh gave you an idea about biochar from the rubber tires, correct? Now, if you delve into this subject, biochar, as the name suggests, this is going to be a activated carbon, sort of, all right, and its applications are tremendous. So, there are a lot of people all over the world who are working in the field of biochar. So, check it out on net, fine, and you will be lucky that in the month of February, one Professor Krishna Reddy would be visiting IIT Bombay, and he is a pioneer in the field of biochar. If you check on net, you will find there are several thousands of biochars which can be created. How? What you have to do is, you have to take any organic material and incinerate it at a very high temperature in the lack of oxygen, or with oxygen also, but with oxygen is not going to give you char. So, it has to be lack of oxygen, and then it gets converted into biochar. Good example is what nature has done. Several lakhs of years back, most of the vegetation got buried in the sediments, and the temperature kept on rising, and there must be some fire also, and because of that, what happened? The buried wood has got converted into coal. If you crush coal particle, make them very fine, it is nothing but the char. Got it? So, this is the linkage between what you are asking. So, some chemical engineers would like to convert tires into biochar. Biochar can be a soil amending material to enhance its productivity, yield, fine. That is the best thing which comes to my mind. Any other thing? And of course, Prathan Singh has shown you application of rubber tires, shredded rubber tires in concrete, aggregates, and apart from this, Prathan?
So, like as a thermal barrier, so but
thermal barriers, yes.
Application wise, like currently it is not being used, but
potential
like
application,
where
people can do research and application work.
So, for sound insulation, vibration
barriers,
dampening,
crash barriers. You must have seen on the racing tracks, velodromes. What do? They keep these rubber tires, for impact negotiation. That's a good application. Apart from this, yes, in maritime engineering, major application. What do you see on the boats? The tires are hanging. Similarly, on the ships also, they use rubber pads. Fine. Now, if it is not the height of imagination, what you can do is you can make sheet piles out of rubber also, so that they will not ever get corroded. So, in the dockyards, where the biggest problem is how to create the confining area, dockyards, you remember?
Yes, sir.
You use sheet piles to retain the soil. There you can insert sheet piles made up of very stiff rubber. And for impact protection of the concrete, what do? They coat rubber membranes or the rubber tires on the piles, decks of the bridges also, piers. all right. So, these are the applications, several applications. Some are related to construction industry, some are related to chemical engineering, chemistry and bio, because on this chart bioactivity should be there. Anything else which comes to Dr. Surendra? Would you like to add something? Biofuels. Oh yeah, sorry. Yes, yes, please elaborate it. It didn't click to me. Yeah,
So
go ahead.
Sir,
It's a huge business. Yes,
sir, similar to that WTE process, so there
Correct.
are different processes, incineration, pyrolysis, and then one of the processes how to get bio oil from the heating of these materials. So
Correct.
particularly from these rubber tires, bio oils can be obtained, which can be used.
that's right. So you can melt it, you can take out the oil from this, which can be utilized. Anything else? Okay. So there are several applications. So please check it out and share links with us. I will also share some links with you if you remind me. Okay. Then let's move on to the today's interaction, and this is related to these. Yes, interaction number 6. Many of you have been asking about the environmental impact of the landfills. If you remember, somebody has asked this question in the second lecture, and I have been telling you that this is where the real application of geotechnical engineering and environmental geotechnics starts. So I have tried to put these concepts in this slide form. This is scenario number 1. The mound which you are seeing over here is the landfill, which is sitting on the ground. Mostly these landfills were created as the dump yards. You know this. At the base, no protection was given because they started 100 years back, maybe hundreds of years back. And they kept on dumping. So it has become a huge mountain of the waste. Fine. So now what happens? This is something very contemporary where people are interested in finding out waste environment interaction. How waste is going to interact with the environment. And what is environment? Sun, heat, humidity, temperature, rains, bioactivity and so on, correct? And put together everything. Ultraviolet rays of sun will degrade something, plastic, rubber also, correct? So everybody is interested in doing mathematical modeling of waste and environment interaction. It's a big subject in environmental geotechnics. Clear? Now what's happening? The simplest possible form is precipitation, rains. So when rains will come, they will migrate through the waste unless you cover them from the top. Covering them from the top is not an easy proposition. I think we have discussed this because it requires a lot of money. Number 2 is waste is supposed to get decomposed. Decomposition means volumetric deformation, and any organic material which gets decomposed, you are going to have leachates, liquid phase, you are going to have gaseous phases which are nothing but what you smell every day morning or late evening in IIT campus from the landfills. Gases, different types of gases, all right, mostly methane, mostly, or H2S, or different varieties. Now PFAS is also added to that. So this list is ever increasing. Now we want to stop these emissions. These are known as landfill emissions. How to stop it? Because otherwise the whole society will be facing the impact of this. So covering is very difficult. Fire is another issue, and most of the time when you cover it, this is what is known as capping. CAPPING, capping. So capping is not, number 1, economical, number 2, very risky, number 3, when the decomposition will occur, the chances are the capping will also get distressed. Distress means undulations, very difficult. Fine. So it's not easy unless you do a proper engineered landfill. Now what's going to happen? Another thing is you have water table. Most of these dump yards are near salt pans, marshy lands, the lands which were not useful at that time. ponds. Otherwise, if they were useful, people have utilized it. So, that these were really dumping grounds, fine. So, what happens is because of fluctuation of water table also the water may ingress with the or ingress and interact with the waste component. So, ultimately what is going to happen? Ultimately, there is a plume which will come out which is known as leachate. Somebody was asking this question, what is leachate? Okay. Now, this leachate is a chemically loaded toxic or hazardous fluid. That means it will have gases, it might have semi-solids, it might have this might have even suspensions of the solids, it might have nanoplastics, it might have microplastics, it might have liquids, heavy metals. Now, once they are getting spread into the environment, the problem starts, fine. So, understanding is that most of these dump yards have created a big havoc, and that is the reason number of people who are becoming sick either because of the gaseous emissions or because of the leachates going and becoming a part of the water table is causing most of the health issues. Read more about it. And that is the reason all the governments want to remove these type of heaps, so that new engineered landfills can be done. Now, this is one scenario. What is happening here? The leachate forms a plume and this settles down because there is a stationary water table, fine. Most of the time water table is moving. So, here I have taken an example of a stationary water table which is not moving at all. There is no flow of water in the lateral direction. So, this type of plume gets formed. If I rotate this picture by 180 degree, what will happen? This is the emission from the stacks, chimneys of the thermal power plant, manufacturing processes, oil refineries and so on. So, situation is same, there the dispersion is taking place in air. Now, if you take up a course in environmental engineering, there they will be teaching you how dispersion of plumes takes place in the air. We are geotechnical engineers, so our domain is restricted to soils, rocks, fractured rocks, saturated, unsaturated soils, water table. How dispersion of contaminants is going to take place in these geomaterials. These are geomaterials including water, correct, because this is found beneath. So, this becomes a case which is a case for litigation. How? The moment water table starts moving, what is going to happen to this cloud? It will get dispersed. So, I will come to that later. Now, suppose if you are an industrialist and you have created a landfill for your waste product. Any product which you produce is bound to create byproducts. Byproducts are nothing but the waste components. So, what is going to happen? All this is going to remain in your premises. So, from where you will get the water table to take out the water for drinking? Are you realizing? Because you have to drill the wells and take the water out. Major problem. However, once there is a moving water table, now what is going to happen? So, I want to stop this. Now, what happens here is we put barriers. I think I discussed this in the previous lecture, that there could be sheet piles, there could be barriers which can be designed so that there is no spread. Mostly these are made up of bentonite slurry. You cut out the ground, fill it up with the bentonite or cement paste or cement sheets, very difficult process, or grouting which you have to do, precision grouting, not very easy to do. Clear? So, I wish that all these landfill area should have been completely curtained off, so that nothing goes out. This should have been the best possible scenario, but unfortunately it cannot be done. Huge area. Number 2, you are working in the marshy lands. How will you mobilize the construction equipment? Got it? Number 3 is, even if you install something today like concrete, most of the leachates are going to be aggressive in nature. They will corrode the concrete. Understood? These are the problems. So, hope you are realizing that there is no straightforward answer to any question. I wanted to do this at one of the projects at the site, one of the sites nearby, but the cost comes out to be too much. Second thing is, if you look at the hard rock and the ground surface, this distance could be 30, 40 meters. So, how are you going to do a stage construction of the sheet pile or the confinement? That is not possible. You will be studying sheet piles in the next course. Fine. So, these are the challenges. Now, contrary to this, if you take a situation where water table is moving, now what is going to happen? This whole plume will get spread. Is this a good situation or the previous one? Previous one is good for you. But suppose if I have a neighbor and he was operating his water supply system, groundwater supply system, and then one fine morning he sees that something which you are producing and your company is known for is getting percolated in his wells. Now what is going to happen? Have you understood? Two adjacent plots. At one plot, whatever you were disposing is getting deposited and water table is moving, and this spread goes into the neighbor's place. And when he takes out water or she takes out water for his or her purpose, all these contaminants are going to come. This is a litigation case. So, who are required to fight out this case? Because one is going to shut down his or her industry now. Are you realizing the consequences? So, most of the industrial premises, development centers, there are several units which are operating. They were constructed several years back, settlement of foundation has occurred, the tanks which were designed have cracked and all the leachate is moving out, complete mess. Imagine. Fine. Now, how will you come out of this? So, one is definitely I can use the penal system and I can put a penalty through the legal issues, but forget about this, we are engineers. Our job is how to remediate it. Clear? This is where ground remediation and groundwater remediation becomes a very, very big task. I wish some of you should take it up as a startup. Tremendous amount of money, only few concepts, and if you are an expert in this subject, I think you have a great demand. I don't think there are many experts in the country who can handle this. Fine? So, think about it. We need people. Ultimately, what you have to do? You have to characterize the soil and the water which is going from one place to another place. So, I will be discussing later on characterization tools, the way you do blood sampling, serum testing, correct? And I can tell you what is the problem, how much concentration is coming from one place to another place. The concept is this. I hope this must have given you an idea about, somebody has asked this question in the previous lecture, I said wait for some time. This is what is known as EIA, Environmental Impact Analysis. So, as an industrialist, if you are going to set up your industry, the first question these environmental agencies are going to ask you is, where is the DPR, Detailed Project Report. A DPR should include, I am going to produce this, but at the same time I am also going to produce so much of byproducts which have these characteristics, and the groundwater profile is this, hard rock is somewhere here, and seasonal variation of water table is this, fluctuating top and bottom and so on. Now, this becomes a very big issue. I am just telling you in small words, because the cost associated with remediation is going to be enormous. It's a groundwater table, you cannot pump out all the groundwater, keep it somewhere, treat it and then refill. Hope you can realize this. So, these projects require a lot of expertise. One of these types of projects we are handling, in fact, Mr. Sohan is handling, he is our captain, and if you want, we can take you there, but it's almost a 5 hours journey each side, correct? It's a beautiful example of how industrial situations lead to legal aspects, and then what is your role as a techno-legal advisor for a company. Hope you are getting this feel. Okay? And then comes all these policy issues, what should not have been done, how it has been done, who allowed them to dump here, who did not allow, why the police or the law did not restrict this dumping and so on. So, it's a big subject. The challenge here would be, I want to understand if I am dumping the waste somewhere or if I have dumped waste somewhere, what is its extent? Now, when we talk about the extent, there are two terminologies. One is distance which is known as spatial. Fine. Space, x, y, z. Number 2 is temporal, time. So, truly speaking, this is a 4-dimensional problem, x, y, z and t. Clear? So, one of the design problems would be, if this is the disposal point or there is a facility of disposal here, whether the population which is staying at 50 kilometers away is safe or not. Because tomorrow if they start pumping out water from their facility, nothing which is toxic, hazardous should affect them. Got it? And that is the reason you must have realized most of the industries, when they were created, there was a strict norm that within the radius of this kilometers, there cannot be human settlement. Got it? Imagine if I replace this landfill with nuclear waste disposal site. So, what I have done? I have gone a leap beyond expectations. Municipal solid waste would be having some toxicity, some hazardicity, correct? Now, I have gone to the radioactive level. So, if you are operating a radioactive facility, even if it is, let us say, therapy or radiation, weapons, medicine, pharmaceutical, irradiation of agriculture products, everywhere you require radionuclides, correct? So, that means you must be dumping the waste somewhere, and in case by accident, by earthquake or by any other fatality, if these species come out and become a part of the water table and the soil, what is going to happen? This will be harakiri. I hope you are realizing the extent of the problem. I am not doing any mathematical things right now. I am just giving you an idea about what is the domain in which environmental geotechnologists work. Fine? Is this okay? Any example which comes to your mind, which you would like to cite here? Yes, please use the mic.
So, I want to ask that this leachate that you are showing, that is spreading, is a gaseous form or it's in liquid form?
Most of the leachates would have all the phases, gases mixed in liquids. See, gases also liquids, no? In water, and then having suspended particles. So, it is a 3-phase system.
So,
you will be having water, you will be having gases, you will be having some suspended particles, and they are all moving. And then add to this microbial activity. COVID time, waste was being dumped without knowing. So, microbes, virus, fungus, everything is also a part of the leachate. This type of modeling became very necessary at that time. So, in India at 2 places, we were planning to do this. Yes, please, go ahead.
So, sir, if that is in liquid and gaseous form, so this situation where the water table is fluctuating is like more good in terms like the gases won't be traveling so far, and the more hazardous state is gas only.
Always remember, water is a carrier. Clear? In soil mechanics, you have studied, no, transported soils. How did they get transported from A point to B point to C? Transporting agency, water, air, glacial activity, correct? Fine? 3. So, water, whenever it is present, it will accelerate the process of contaminant transport, which is a very big subject in environmental geotechniques. There will not be advection, there will be diffusion or combination of the both. Got it?
Sir, but that diffusion will be retarded because of water.
Water liquid phase always accelerates diffusion process.
Not for the liquid, sir. For the gases, it will.
Gases also, why not? What is CCUS? Correct? Mr. YNS. Passage, connectivity of the pores. In dry pores, nothing is going to happen. You keep a dry rock, nothing will happen. Dry soil, nothing will happen. Conductivity increases when the pore fluids are present, not the gases, liquids. So, this concept you will be studying later on, saturated and unsaturated soils. So, saturated soils are the ones where the pores are filled with water, clear? Unsaturated soils are the ones where the gases are present. Gases present in the porous media will impede, they will not allow transportation of contaminants, but gaseous phase they will allow, but water present will allow both. Fine? Okay, so what's your question?
That's only the question.
No, it's not the question, these are facts. Now, what is the question?
that was only the question. Like this situation will be better if we actually think that this water will retard the diffusion, but if actually water is
So there is
certified.
another, you are aware of that, there is something known as molecular, dispersion and dispersion. 4 mechanisms are there: advection, diffusion, dispersion, molecular dispersion. So when you are having contaminants which are diffusing, gaseous phase or liquid phase depends upon the velocity of the flow also, that becomes coupled. I don't want to introduce all these concepts here, slowly, it's a long way to go, correct? Let's make it simple. It's okay, fine. Any other question? Hydrodynamic dispersion. Yeah, it's basically hydrodynamic dispersion, correct. You want to say something else? Okay, good. So basically what we want to do is, as a professional, we want to understand what is the extent in time and distance. Number 2, what is the intensity? If I am throwing out something from my industry at a certain concentration, chemical, radiological, biological. On a agricultural farm, whatever you are producing is bio waste, correct? Now this is getting disintegrated, fermentation, microbial activities and so on. So they will also get flushed out. So in geotechnical engineering, environmental geotechnology is another subject which talks about bacterial flushing. Become an expert in this subject. So one is only contaminants migrating heavy metals, clear? Mercury, cadmium, iodine and so on. Number 2, radioactive material. Number 3 is viral activity, microbial activity and so on. Now how the interaction between porous media and these activities is going to take place, people have to study, they are doing it in fact. But this is a big subject, fine. Intensity, because intensity is regulated by the regulators, pollution control boards, US EPA, all these watchdogs of the environment, because they will tell you that tomorrow if I dig a well here which is known as observation well, what type of contamination is coming from where, they can trace it out. And then this becomes very difficult thing to deal with, fine. And then comes the concept of modeling. So I have to stop here, why? Because by the time we come to the modeling, this year will be gone. Why? Why do you use soil to, you use soil as a cooling agent for your body? You use soil for facials also, for cleansing your skin. That means there must be some cation exchange capacity, surface area, all those things. You have heard about it? Now when the contaminants are passing through this, they have a tendency to cling on the particles of soils, distribution coefficient, this, God knows what. So please watch my lectures on Ce488 environmental geomechanics, where I have dealt with these topics quite in details. And read as much as you can, because there is no substitute to reading and understanding, fine. So for mathematical modeling, what do we require? We require parameters. What are the parameters? Parameters of the geomaterial, soils and rocks, and number 2 is the characteristics of the waste components. Chemical concentration, their temperature, half-life, and what else? Their pH, of course, then what are the elemental composition and so on. Then this becomes a very intricate subject. Hope this answers your question. Got it? Any question now? So this is a very practical situation, and please realize. Okay, now let me invite Mr. Vivek.
Like today I am going to present on the topic I am working on. It's the application of the waste material that is being generated. It's about municipal solid waste and the industrial byproducts. So basically, Professor has mentioned about the impact it is creating and the amount of municipal waste and these byproducts are being generated every year. So these are some newspaper headlines. And the impact is basically, as Professor has mentioned about the impact in his slides earlier, that it can be from the methane emissions to groundwater pollution, from groundwater pollution, air pollution, microplastic hazard, and hazard associated with it, to the shortage of land. Basically, the impacts are due to the impacts we are going we are going for its application part. So application is basically on these application is basically from using it as a product and using it as a energy source. So in case of waste to energy, Dr. Surendra has mentioned about different type of refuse derived fuels that can be used, and different type of electricity generation from these waste materials. So in the waste to product part, this is the basic from this approach only I will be like, from this approach like my topic starts, like I've used the waste material and I have created the product out of it. So like we are covering some SDGs as well.
One thing you can emphasize upon is that waste which is lying in the landfills, particularly in the form of the plastics and polymers, what is the major issue? Because segregation was not done ever. Clear? Now this polymer and polythene or polymers of any type, they are going to degrade because of the heat and pressures present in the landfills.
Yes.
Every day height is increasing, so stresses are increasing, heat is increasing, correct?
Yes.
They weather, they degrade, and then what happens?
Microplastics,
Microplastics, nanoplastics. Today morning also I have shared one link on rubbers, microplastics, which we could not do so far.
Yes.
Yes.
Yes, to know about what is the waste made of, like the source of waste. Like everyone, we are the contributor of the waste. Like as in the municipal level, we can see that different type of waste are present. So from food waste to like metals, plastics and all. So in this category, I have selected the plastic waste because it is one of the major waste present in the landfills. So one part is the plastic waste being generated in the landfills.
So just for your information, when I was dealing with one of the landfills in Bombay City, which has already been closed, each meter of waste material deposition is equivalent to 1.5 years of the history time. So we went up to almost 35 meters deep, and we could get the wrappers of that era, and one of the wrappers, it is written that year. So what it tells, it never gets decomposed. Got it? So one of the major issues is that if you are doing biomining, removal of the landfill, this material is not going to degrade. What is that you are going to do? It's like spilling beans, much more. So one volume has got created into several volumes of inerts. Now what to do? That's the major question. Okay, please.
So like we are taking the plastic waste from the landfill, and with this we are like using the using industrial byproduct also. Like we are dealing with both type of waste material from the municipal level to the industrial level.
So ideology is like this: when you create concrete, you require a binder, which is cement, and you require aggregates. Aggregates come from the rocks, correct?
Yes.
So then the same similarity.
Yeah.
What you are doing is you are using plastic as a binder, and then all these are known as filler materials. Yeah.
Yes. And these are some of the industrial byproducts, and different type of like steel slag, red mud, phosphogypsum, and landfill mine soil fractions are there. And Professor also mentioned different type of IBPs as well, from dress sediments to various others. So like my focus is basically on the red mud, which is a bauxite residue obtained from alumina, like while obtaining alumina powders. So I am taking the red mud, which is like we can see the heaps of red mud lying in the alumina generation plants, and plastic waste from the landfill. So we are basically first the plastic waste is in large sizes. So we are cutting it into small pieces.
Untreated. We are not
untreated.
treating
Yeah.
the plastic because we don't have water.
Yes.
Got it? That is the beauty of the whole process. Because if treatment is required, washing is required, we don't have so much water to drink even.
Right.
Nobody is going to buy your technology. Now he is heading towards a technology demonstration project. So he has created a technology. Yes.
Yes, like by the LVOP shredder, we are basically cutting it, and the plastic waste along with the red mud is at various content of red mud. Like we are basically playing with the content of red mud at what content like we'll get the proper composite material. So by using a mixer, we are mixing these shredded plastic and the red mud. So after that, the mixed, the homogeneous plastic and red mud is fed into a fed into a extruder, sorry, and extruder consists of thermal plates. Like it, with the help of searing process and thermal plates, it get shredded, it gets seared and melt in the.
It's known as extrusion process. So metallurgists would know it better, extrusion, or mechanical engineers.
Yes.
So this is the first time I think in construction materials something was extruded when we did this work. Okay.
Yes, and after the melt has been obtained, it is molded using compression molding machine, and for creation of these bricks, and we have also created aggregates as well. And by using various with the same process, we have cut the melt and created the aggregates. So last in the previous class also we have shown you the bricks and aggregates. These are the material that has been created by the similar process.
So couple of USPs.
And
These materials were leaching, correct? The industrial products. Once you have interlaced the particles with the adhesive or a binder, the end product is going to be very stable because thermally it has been treated. So there is no leaching which is possible. So it is a one solution. Most of the industries are now looking for solutions like this. Fortunately, we have mastered this technique and we want to explore applications as many as possible. Most of the car manufacturing companies are also interested in utilizing their rubber and plastic, for creating. I mean, this is the sustainability, circular economy, marketplace, blockchain analysis, and then creating policies so that government can enforce it on builders and the landfill operators, so that this material has to be recognized as a man-made material and it should be used, the end product should be used in sustainable construction. So this is where our focus is mostly. A lot of efforts are required in terms of upscaling of the entire thing, but now there is an awareness and we are happy that we have already delivered several products. We were discussing the other day ZLD, correct? Zero liquid discharge. Now this will be zero emissions, even gaseous particulate matter also, that can be done easily. So everything will be in a concealed closed system and then I can take care of this. Well, your point is very valid, that if you don't do it properly, this is what is going to happen.
yeah, it's about 13 to 15 MPa.
Much better than the conventional bricks. Where is the soil for making conventional bricks now? Number two, there are limitations, porosity. My system is totally impervious. I can contain any waste in this. Just can you please wait outside? He must be coming, Professor Bhargava. So, that's another thing which I have attained. Strength is not the only thing. In concrete technology course, you must have been taught durability is more important. Got it? Nobody is interested in knowing how much strengthful you are. How durable you are is more important, correct? 50 years, 60 years, 90 years, 100 years. So I want to make a structure which gives me minimum possible strength, but more durability. What you require now is durable structures. Got it? So no porosity. Chemically inert, yes.
You had mentioned that red mud is extremely alkaline. So how in the production process, how do you handle that? How do you work with it?
Yeah, basically we are now using some gloves we are using to handle it, not the gloves and mask basically while creating it, And
That
some
precaution we can
remedial
take,
measures-
but answer to your question is that we are not doing any treatment to any of the waste material, because that is an added cost. The moment you add cost to the waste, your whole purpose gets defeated. Please remember one thing, this was a material of no use to anybody, clear? Now you are creating value out of it, you are not supposed to spend even a single paisa. I hope this is what you are asking. All handling part and all I can take care of, that is not an issue. We are not cleaning anything. The way it comes, maybe I can alter the form a little bit. It was very wet, I may squeeze all the chemicals out and I will have that, what do you call it,
Dry.
cheese. What do you make out of it? Shrikhand. Yes, something like that. Correct? That is also porous system. Yes, please. Yeah, next question. Yeah, yours is done.
Are there any chances of gas emissions during the heating phase?
Yeah, we are facing some challenges as well, like while creating it, from handling the red mud to emission of the gases. But it is basically the work done by Dr. Goli from our lab. And
See, the point is all these emissions can be taken care of. Today's is a technologically advanced era. Clear? You want a closed loop system? Yes, that can be created. That is not a very big problem. So, when you delegate research from laboratory to the pilot to the field, which is known as TRL, technology readiness level, the question asked is at what level you are, 9, 8, 7, 6, 5, 4. So, laboratory approval means that you are quite close to 9. 9 is the magic number, I think. TRL 9, correct? So, TRL 9 is supposed to be the technology which can be utilized immediately. Fine. So, we are at 7, 8. We have shown at pilot level also emissions alone can be controlled, but then the cost of the equipment goes up. So, right now everybody is interested in seeing whether your proof of concept is valid or not. Clear? So, as a technologist, as a researcher, what we do is we just try to create knowledge and show that whatever we are doing is valid. Got it? Yes, please carry on.
no, it has been made at around 160 degrees Celsius. So little temperature, I don't think it will like.
Ambient temperatures will not matter. Even the temperatures which normally get exposed on to these geomaterials or the concrete will get exposed also will not going to make much difference. So, for this there are specialized tests which you have to do, which are known as thermal property tests. So, I will cover a little bit of that later on. So, then it comes the material characterization. Before you stamp that, see, my product is worthy of everything, it can sustain all sorts of this parameters, correct? So, that test can be done. Yes, please.
How is the composition part playing a role in this? As you mentioned,
Yeah, yeah.
you are doing it at
Yeah, composition is also like during the chemical properties like pH level, there is slight increase in the pH level from using 10% from using a low like red mud content to high red mud content. So chemically, but it is not in the like not on unacceptable range. So from 7 to 8 it is going on. So not like from 13% alkaline red mud we are reducing up to 7 to 8% pH. So 7 to 8 pH level. So it is not causing any difference on that. And strength wise it is quite uniform. So
See, technology is all about what nobody thought about, correct? It might be making 1 plus 1 equal to 2 or showing that 1 plus 1 is not equal to 2. So, never think that creating technology is something extremely out of the box. It could be very simple thing. The question is how easily it can be implemented. That's it. Yes, sir, please come. Professor Suresh Kumar Bhargava. We should be proud of having such Indians who have made name for themselves in the country.
Guys, you can see my name and probably the things as well. I feel privileged to be a place at IIT Bombay and also to your class, because I know that you are the intelligent minds of India who will make the difference tomorrow, I believe. What difference you will make, time will tell. Right. So what I'm going to talk to you about is that looking beyond the boundaries. Sometimes, you know, when you take the class, when you're doing the things, when you are studying like this polymer composite, you are talking about the red mud, you're talking about the different things, different innovation there too. Then you start thinking about it that, okay, yeah, right, I am making a polymers. Should I need some extra knowledge of the polymers? You know, should I read something about it beyond these disciplines to go there too? Can I mix those discipline boundaries? Is in there too, right? And good news is there that AI is available. So Dr. Google will tell you most of the things. If you just search it, it will tell you. You are the smart guys, is know that too. Because reason I'm telling you, there is about 40,000 apps are downloaded per second in this world. 40,000 apps per second. Can you believe it? What it means that we are racing. The mind is racing with the AI, with basically the artificial intelligence or the thing as well, technology. Technology is racing with your thought of minds is there too. So that is the world we are living into there too. And question is there, this is the time where we should or you should think about that, are we updated? Are we updated with the technology? If we are not updated, we will be outdated. The rule is very simple. So I will tell you certain things as well. Well, before I tell you, that's my journey for 35 years. I work luckily in the two worlds. One is the half of the world is going to the industries, all kind of industries, mainly resource sectors. And in the resource sectors, you know, I was lucky enough to be having a board of director of the Aditya Birla Groups for 9 years. Vedanta Groups in Indian companies, I associated with them to establish there because the India is always looking for the resources. The demand is more than the supply in this country. So you're always looking for that too. Secondly as well, there was always environmental issues. The moment you touch any soil, the moment you touch any water, there is environmental issues, right? So you have to think about it, in what ways, what are the innovative ways when I touch these things is there, then I leave no footprint which can damage the nature, because damaging the nature is disaster, right? That's why there is a lot of emphasis on the green hydrogen energy. There is a lot of emphasis of find out the new ways, because disturbing the nature, you have seen just 3 years ago, what happens to the COVID. You disturbing the nature again, that you left the footprint of the mines untouched or dirty after taking out. Now you will be punished for that, isn't there too? Remember, whatever we take from this world is a loan for the next generation. We have to pay it back. You take it today for your advantage or your luxury, you have to pay it back for your children's. When they are coming, they would like to see, is there anything left or everything has been used? Remember those things as well. Let me be a little bit provocative, straight way. I ask you a question in this, when the business connect with the industries or higher education, when you go to the market, what is the situation? My question is there too, does the faculty really understand how the decisions are made in the business and the industry? They do really knows. These are the two words, I saw the two words. Two words are very different. Business exists only one principle, profit, nothing else. If you can't make $1 to $3, you don't know how to do the business, right? On the other hand, knowledge is there. Knowledge is not designed there just to create. Knowledge has a little bit of more to offer. So we have to find out the way. But when you talk to about, then you want to be employed in the world, America or Australia or to UK or somewhere else, or even the big industry MNCs there, then the question comes. A lot of the times business say these students are useless. They don't know how we operate. We have to provide extra training to them. There is another 2 years of training. They want to cut down that cost. Could students analyze situation, develop financing and the market a new product? Can you do that? Can you think that yes, I can analyze the customer situation, what the market wants, what the customer wants. So whatever you're doing there, when you're thinking about startups, and I know there's a couple of guys are thinking that way and moving that way, that we want to have a startup. We want to have the startup culture is quite infectious in this country. But how many of the startup will go to success? 5%? 10%? The risk is there that what happened to those 95% or 90%? which goes to the tier 5, tier 4 and then stop after tier 7 because that's it, market doesn't want them. What you do in the lab is different. What excites you in the lab by the science and technology is different, but what the market wants, whether they need your product, whether they want to buy your product, well, that's different, totally different. The question is there, does this lab pupils, you peoples in the class, you people in the lab, do you really understand what the market wants? Can I develop a product which I can sell in the market? If you can't do that, no, you won't be successful. That's important too. How often does the faculty or the university executives engage in discussion from continuous with the business world? What type of the graduates you want? How often? Because problem is there, academics lives their own world. Sorry, I'm one of them too. They live their own box, right? They always advocate very strongly what suits them, not necessarily to the market. They live in their own world. And particularly if they live in a comfortable zones, right? There is a private universities are coming, they are competing, they are coming up forward there too. Well, then it is becoming more dangerous. So that's the one thing. Secondly, to produce the real world employers, we must produce the real world graduates. You want to be employed, in the top industries, you need the real world graduates who can adapt to the organizations. Every Birla has its own philosophy to run the business. Tata has its own, right? Apple has its own. Microsoft has its own. So one thing is they adopt to the organization, understand the job requirement, produce the work that has a clear return as quickly as possible, right? Add values, especially in the short terms. These are the secrets. Relies on the knowledge, because everything you want to sell, it must have a knowledge background. Yes, I can convince the market, yes, this product is based upon the science. This product is based upon the knowledge. This product has been tested. The world needs seeing is believing it. I want to see how it works. So the real world, being everyone knows what goes to the big companies, everything else is immaterials. That's the real world. What is the definition of the real world? What goes to the big companies? That is the real world, right? The market, ASX market, the Bombay stock markets fall in one day, it can disturb the whole economy straight away, in one day, one night, right? The growth will be disturbed, GDP disturbed, everything will be disturbed. Careful about that too, right? According to the American Council of Education, it is the high times that the academic communities start to concentrate on teaching skills. Number one word, attributes to the business requires. Students must be taught to understand the unwritten rules of the corporate culture. Unwritten rules of the corporate cultures. Business needs successful, intelligent pupils. Business does not need the topper of the class. No. Academic needs the topper of the class. Business needs the intelligent person who can quickly see what the market looks like. So that is very important. You see, the Bill Gates, the professor of messy profits, will be the more relevant to the millennium graduate, to you guys, rather than the professor of the obscure topics with no current applications, right? The professor will ask the PhD graduate, okay, we need to publish the papers, good, they create knowledge, but the publications with applications. That is the mantra, publications with applications. Papers sell your knowledge to the world. But usually the papers in the journals sell your knowledge to the peer group only, the people who are working in this field. The people who are not working in this field, that the market, the outside this gate of the IIT, they don't know what you're doing unless you show them a product, unless you show them umbrella, unless you show it some things which they can see, wow. You understand the difference? That's what I'm telling you. And I'm dilemma in the academic world. I mean, I'm a professor for 35 years and it goes, should there be, there's a very terms coming, you should be creative than innovators. Should they be more creative than innovators, or they should be innovators? What is the difference between the creativity and innovations? Look at the definitions. Do you think they are basically the same, or the important difference? Are you comfortable to describing yourself as a creative or an innovator? What do you want? Innovation is an external word that can be seen, that can be measured. It generally describes that have been tested and work in the real world, right? Creativity is more an internal word. It is subjective. It is far harder to measure or define. It is an inward journey, not outward journey. You see the difference? It is the inward journey. I am creative, I am an artist. It's an inward journey. It is not the outward journey. Innovations, and that's why you see the business usually do not use this word creativity. No, they use the word what? Such as value, excellence and quality. Of course, innovation. Of course, innovation. They use these words quite often. Creativity is thinking the new things. Innovation, doing the new things. Translate that creativity. Creativity is equal to ideas. Innovation is ideas into action. Right? Doing the things differently, which makes the difference. It's not always that I'm doing the things differently. No, no, no. You do the things differently, which makes the difference. That is equally important. Just doing the things differently is not an innovation, right? But which makes the difference. That's the important things. Remember, red tape. I don't want to discuss that. That is more than that. Is there? And then now the rule is very simple nowadays, guys. Innovation or perish. We must turn out the research ideas into the real world product or services. New research mantra, take your mind to the marketplace is very important. Before you start producting, you start showing a startup, you start thinking a new product, you start doing a research, just make sure what the market expects from this. Is my research is relevant to the market or not? But we need science, plenty of that. Remember that, all those sort of things. 21st century research requires co-innovations to make the better impact that have a winning course of the lower cost. Very, very important. Co-innovation is the platform to create new values by applying the new ideas or approaches from all collaborators, both internal and external. The power of one is no power at all. Nowadays, you think that I alone can do it? Bullshit. You can't. You can't. You know, if you want to make the real product, you have to innovate the things. You have to co-innovations. You have to work with the different peoples. You have to make a teams. Right? That is extremely important. The Dreamlines, when the product came in the aerospace things, Dreamliners came in the market, 51 countries in 41 labs are working different parts of the Dreamliners. And they collect it there too. That's it. Is in there too. Collaboration, 1VK, is not nice to have it. It is now competitive necessity. It is mandatory. Without collaborations, you will be outdated. Very, very important. In this country, that is important. What it called is the Gandhian engineerings. You must get not more from less, for more. That is important. What means your product must be cost effective. But the challenge will be there, how much quality I can reduce, because quality and the cost goes opposite to each other, right? But you have to, now here the time comes, how much, how can I do it? How can I balance it, right? Like for example, CO2 utilization is very important. CO2 sequestrations, fine, but CO2 absorption and then utilized into the new product, fine, that is the one thing, right? So the mind will invent the things, solution will be coming out there. That's what I'm thinking, think outside the box. Just not that, what my discipline is, look outside the box as well. Okay, sharing the research idea, that's what I'm saying, 1 + 1 is equal to not 2, is 4. Why? Because if 2 persons are discussing the ideas, there's 1 idea from me, 1 idea from me, there's 2 ideas on the plate. When he leaves, he takes the 2 ideas with him. When this person leaves, he gets 2 ideas. Right? Each have now the 2 ideas. One is own, second is what he got the partners. 4. What I did, I make innovation models, and then I see what I see. I put all the several disciplines which interest to me put together. The put together means that they are not sitting in their boxes, they are sitting outside the office. So these about 20 or 40 scientists, time to times, they are working straightway together. The difference was there, they connect to each other twice a day. They take the coffee together, sometimes they talk to the lunch. Different disciplines, they have nothing to do. Additive manufacturing or the mechanical engineering or the electronic engineering, they have nothing to do, but they are talking what you are doing in the organic chemistry, what you are doing over here. And they start talking that what we can do, how we can contribute. And that's why the new product comes. That's why the innovation comes. That is the cycles, and then you can see is the cycles is there, you can see, then we can see the creative schemes, how I work. So it's becoming, whole cycle becomes self-sustainable. I don't depends upon the grants or something as well. If I follow all those principles going on there too, the resources are there, human resources are there, and also at the same times is the, the financial resources are there, connected with the industries, no problems. Funds created by the applied research are returned to the undertake the creative science. The creative science can be translated into the translation research to the industrial product or the industrial problem solvings. That's what the cycle continues. I experiment that successfully. It is working. Still the center is always going up and up, growing, not going down. Building partnership industries, like one example I give you. For alumina industries, you're talking about the red mud. That's why I say that, okay, let us put there 24 years continuations with Alcoa Alumina, with the Hindalcos, with other alumina industries there, with Alcoa Alumina, Australian Alumina Association, alumina industries of, from the air emission problem. Most of the product I did with alumina industries, they are all pollution control related. Like organic removals, FTR and LSA of the bauxite minerals, Rainbow technology. If you look the Google's Rainbow technology of the Alcoa, you will find out is a AI based technologies, and the fundamentals were generated from my lab. I was 2 years for their consultant to Alcoa on these technologies. ATR, FTR, and LSA, the bar liquor solids, both were successful. Technology developed is in there. The organic removal from the liquors. There, the organic fumes comes in the air, VOCs come in the air. By burning, we can remove in the solutions before they go to the waterways. Is in there too. So that's why I'm saying air emission controls, non-technology based solutions. Building partnership with the industries continues. Like for examples, we are also developing the mercury emissions coming in the air from Alcoa. They ask me, we develop the mercury emissions there too. Developing sensor for the alkali mist. If you go to the aluminum refineries, if you go to the experience, you smell. The moment you are approaching to the aluminum refinery, you can smell. That is the alkali mist. The Alcoa asked me, Suresh, can you prepare a sensor? Because these neighbors are suing the Alcoa because of that, okay, we are smelling, we are getting carcinogenic, we are getting cancer, all those sort of things. What is the limit? Are they going beyond the limits? We develop a sensor for them. Low molecular weight, volatile organic compounds detection in the airs is in there too. And all involved in this all process, we involve PhD students because they do learn in the real seeing believing. And then what happens there too? That's what I'm saying. The problem solving to industries. I work with the oil and gas, uraniums, aluminiums, copper, coals is in there too. So that they are my bread and butters because that's what the Alcoa has nearly about at least 20% of the world resources stays in that countries. You name it, they're there. But the uraniums and everything is there too. And then we develop the technologies, alumina industries based on the VOC detection in airs and the catalytic wet oxidation, removing the organics, liquid formings is there, ATR, FTR analysis. We develop all those technologies all by PhD students and the PDF as well and the industrial partners there too. But whenever we take the project, we always involve a industrial scientist from the day one. And we always involve regularly, are we on the track or we are going out of the track? So you can say no, students are doing their PhD, they are the knowledge generators. PDF is doing yes and no, why it fails, why it is successful, how we can improve it, all those things. That is the model, we go there too. For examples, I give you that this is the technology we develop the mercury sensors. We take the mechanical engineers, we take all those things, is a QCM crystal based, is in there, which can detect the mercury on the parts per million levels, is in the airs, and manage the things as well. So all these technologies developed from my labs is there too, and it demonstrated to the companies that okay, it can be done. After that, they can go. The proof of the concept is there. After that, they can take on the different levels is there too. Two types of the impact. The another impact is the academic impact. I'm a professor. Professor published the papers. Professor published the paper with the cover page. Professor want to see that yes, delighted, of course. Grant is going up, student is going up. All those things are continuously going up is in there too. We work with all these industries. I work, this is the old presentation, trying to make it up to date today, but we work 10 more industries nowadays, but these are the industries which works with us for the last 20 years, 30 years with me as well. Then after working with them, there is a trust partnership is developed with the industries and the group. They ask me, Suresh, when you start solving the problems, the business is very happy because we are solving the millions of dollars problems. What we can do? Then I say, okay, if you really want to do, okay. Then we did the two things. I asked them, they pass a 7 years contract with the Armat University when the class will learn all their lectures at the refineries. West Australia, 4 hours by airs, right? My whole engineering class goes to the Alcoa for 7 years. That become part of their curriculums. They learn the theories in the class and they see their operation in the real world. And you can see, and they are amazed to see it. Amazed to see it. They say, we never see this kind of a thing. So they are very, very funny, and that course become very popular. That body class goes to industry. It was not an industry visit, remember? The lecture was taken, 4 lectures are taken by the CTO. CTO is the chief technical officer of each refineries. He is or she is taking the lectures for the whole class. He and she will be involved in the assessment as well, isn't there too? So that was the things. And the second one, what we did is there too, that when we say, is there to that when the industry come to the class. The 2 programs, I say, okay, these are the top scientists who are working for 20 years. Now we have a lot of people I've met in their POP, Walcott is the professor of practice over here. So they, instead of that, I call them these peoples from Ensto, CSRO, Rio Tinto, BHP Billiton to take the class. 4 lectures is in there too, 1 unit of the class over there. So my recommendations to the graduates, practical industrial experience in Australia overseas, that is my recommendation to them, to my class. Your recommendation to here to go to the Indian industries, definitely Tatas, Birlas and all those sort of things, see there too. Additional skills, always learn the additional skills, go to the MBA PhDs, I introduced there too. Other languages, a good communication skill. Your communication skill is the 50% success. 50% problems are over. If you are good in the communication skill, both writing and communication, your 50% problems are over, right? Effective communication is very, be innovative. Ability to focus on your strategies. You know, what is my strategies? How can I focus? Ability to develop the products or technology which has at least potential to commercialization. That's important. Personality of the candidate is very important. The career is no longer vertical growth. It's a series of experience that help you discover your strength. It's not a vertical, I'm going to BTech, then MTech, then a PhD, and then blah. That's the academic growth, by the way. No, it's not, the real growth is there too. And whatever you do, remember these things, be passionate, right? You know, if you love it, I know you will fight for it, right? You will work harder for it. You will want to make sure it is perfect. Knowing that details matters, you will inspire everyone working on the project to share the passion. There is don't do anything which your heart is not there, don't. Because the excellence won't come. If you keep the bar low, you will never be great, just okay. You know, whenever you talk to this person, how are you? I'm fine. That's the answer, standard answer. How are you today? I'm okay. Is okay is good enough? Okay means that you are 9 to 5. You understand? You are 9 to 5. You choose. What do you want to choose? Your life. You want to be a 9 to 5? Or you want to see beyond 9 to 5? No, I want to make a difference in this life. And if you want to make a difference, then okay is not great. The enemy of the greatness, your passion is the key to the success. Translate sometimes when you say, I have to do it, I love to do it. See the difference. See the difference. The remember is there, that is the mindset. Mindset is very important. If your mind is not there, what you want to do. Suppose your mind is not in the class, you won't enjoy this lecture at all. No. Because your mind is somebody's waiting outside. And no, she'll be waiting too long. No, I have to go. You see what I mean? Your mindset must be attached. What you want to do is very important. That's why I say, the 30th January is coming. I was thinking that, and whenever you do the different things, you will find there is a lot of people out there who's having the gun on you. They want to fire your ideas. No, you're not experienced enough. No, you can't do it. And the important thing, the first, they will ignore you. That's the Gandhian things. Then they will laugh at you. Then they will fight with you. And then you will win if you are persistent. Remember one thing very clearly, the great peoples are not born in the maternity ward. The great peoples becomes by their challenges, resilient, hard work. In the Indian systems, it is very good. Even the king has to go to the Gurukul, have to study just like an ordinary person. You see the precedence there? We are growing up, I have grown up, you are growing up to some extent, is still in the mindset of the Macaulay systems, what the Britishers did. They want to create the slaves. They don't want to create the scientists. That was reserved for the Oxford and Cambridge. And if you do the good jobs, they will transfer to you there. Macaulay clearly says that to rule over India is only one way: change the system, change their mindset, and you will rule over India for over generations. Because what they have done, they have told us, they have put in mind our parents, they have put in mind to our system as well. All the education system, well, white is great. Whatever they are doing is great. Their accolades are great. Whether you are FRS or all those sort of things or knighthood, oh, they are the great. Even the value of the FRS in India is as good as in England, even more. If you go to FRS, you are guaranteed your top job in India. But is the Fellow of Royal Society is the Royal Society of England. And if you also get the knighthood, well, brilliant. You will straightway go to the Prime Minister office or somewhere else. Maybe not nowadays, but that. But knighthood is where you spend half a day with the queens. Queen was not even a graduate, right? Why? Because the mindset is like that. Whatever the British system has given to us, that is supreme in the world. Why? 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 I ask a question, why? Why? Our system was a great one times. Our system tells us that the people are coming to educate to India. A lot of people are coming to, IIT is a great brand names there too. IIT create the graduates, a brilliant graduate CEOs all over the world. Why not the word comes over here? And it is happening. It is happening. And that's why it is happening. And that's why sometimes I question to myself, is the Gandhi reborn? Is the Gandhi reborn? Is this man who is trying to change the mindset? We got a freedoms from the Britishers. Now there is another freedom movement to change the mindset of the slavery, to change the system, to think what you are, to think what you were, to think, can you think differently? In this country, you have all diversity. Diversity is the biggest strength of this country. Go to the top, to the bottoms, right? Problems are everywhere, is a problems everywhere. In India, no shortage of problems. In research project, 50% goes to the problem identification. So you start from 50% up. Because problems is already there. You pass into the Powai Lakes, you see the problems there, Powai Lakes, plenty of problems. You pass through there, water is going through there, plenty of problems. The mindset is not there, can I do something here? And also if I do them, the value of doing things, that thing is not there. The value has to be recognized. The value should be as good that doing a project, publishing a paper, it should be as good, should be recognized that he solved the problems which was not solved for the 10 years. And you think about it, if you can do a good project, if you are thinking about a very complicated problem to solving there, why can't you solve the local problems, which you know how the problem is generated, how the problem is growing, how the problems can be benefited. All the three things in front of you. But what is missing? Mindset. Motivation is not there, is not there. The value of that motivation is not there either. So that's what I'm telling you, that why there too. The free from India, the free mind. You must feel proud to solving a local problems scientifically, technically, as you solve the problems in your project. If that is not going to happen, it's not going to work. And that's why I say, this is the programs, this life is a great chance. I'm the follower of that. Seek for the highest, aim at the highest, and you should reach the highest, right? So remember one thing, that your journeys, whenever you go, you learn from everything. So I'm not criticizing that system or whatever the system is bad or good. No, you choose. You learn from all the books, but don't copy those books. Then you write your own book. Learning is a process where you learn from all over the world, all over the language, all over the literature, what is available in the world. Learn from them, no problems, no problems. But then you develop your own book, your own things, your own ways, which can suit your solutions, your problems. Okay guys, I think I finish in times exactly. I came from this university, which is the highest tertiary university, technical university like your IIT is. I'm there for 35 years. There is in there, but I'm serving India all the times. I'm coming there all the times over here because I decided to be staying there because I can become a link between the two countries. I have become a link. All the ASRF grants, all those sort of things, And not only that, I was honored by the Queen, again Queen, I didn't like that too, but he honored 2 years ago as a Padam Bhushans of India by strengthening the relation of India and Australia and contribution to the higher education, which is I'm proud of that, that's all right, because that is my working country, I have to respect it. They are the one who gave me all the opportunities to do the things where I stand for today. They also give me the opportunity to link these two countries together. They also give me the opportunity that I can serve back to the country as well as serve to that community as well, linking the two. They also give me the opportunity then I can talk about the two cultures together, that there is a things. They also gave me the opportunity to think globally about that too. जब मैं एक छोटा सा, आप लोग हिंदी समझते हैं, जब मैं एक छोटा सा 5 साल का होऊंगा या 6 साल का होऊंगा, तो I used to live in Meerut, yes, it was Meerut, and about 7 o'clock around the same times, there was a temple, and the moment the आरती शुरू होती है ना, तो हम भागते थे, क्योंकि वहाँ पे मेन चीज़ तो थी आरती थी, लेकिन प्रसाद मिलता था, मिश्री का प्रसाद मिलता था, तो उस समय लालच था कि यार मिश्री का प्रसाद मिलेगा ना, लेकिन उस मिश्री के प्रसाद के लिए आपको वो आरती में अटेंड करना जरूरी था आध घंटे के लिए। तो उसके अंदर एक स्लोगन था जो मेरे दिमाग पे छा गया। उसमें जब भी बोलते, जब आरती खत्म होती थी, उसमें यही होता था कि धर्म की जय हो, अधर्म का नाश हो, राइट, प्राणियों में सद्भावना हो, विश्व का कल्याण हो। तो मैं कभी कभी सोचता था यार चिकन तो खा रहे हैं यार, ये प्राणियों में सद्भावना कहाँ से आ गई। और विश्व का कल्याण क्यों? पाकिस्तान तो बिल्कुल अटैक किया बैठा हुआ है, चाइना तो बाकायदा 62 में मार रहा है, क्यों भाई उसका कल्याण क्यों? आप समझ रहे बात को? तो वी ऑलवेज थॉट अबाउट द थिंग्स, वी ऑलवेज थॉट अबाउट द स्काई is in there too, because we always thought that it is the humanity, it is the universe we came from. Okay, so guys, thank you very much.
I thought that you are going to talk about sequestration.
No, I think I thought about that too, but that is a technical talk.
Okay.
So I mean, that's,
Let's take few questions.
any questions to you? I'm more than happy to.
Please feel free. He is a chemist by profession, so I wanted to learn some chemistry of sequestration from you.
I think we are developing the, like for example, we are developing the carbon, for example, the bio-waste carbons. And when we create the bio-waste carbons, so one of the things is that we talk about the bio-waste carbons, and then we develop, so there's a lot of people are using the bio-waste carbon. Carbon in the fibers, carbon is the graphenes, carbon is the graphite, and all those things, carbon is getting a lot more use.
Char
and why the carbon is important there? Because it's coming from nature, it's waste. Is a waste things there.
Biochar also.
Biochar as well, that's what I'm telling you. But then the trick is there, how we can add the values out of it. So my group is doing as well that they are activating these biochars. So they can make in this all these materials, the couple of things are very important. Their surface area. What is the surface area of there too? There is also their porous structures. What is the porous structures there too? Nanostructures, porous structures, macrostructures, how they can absorb, right? And what is the use of it? What is their stability? You know, how they will react with the nature is in there too. So two things which is coming out from my group, which I'm excited, that we develop a methods that we can create, we can transfer this 50 or 60 or 100 or 600 square meter per grams biochar into 3000 square per meter per grams. 4,000 square per meter per grams, 2,000 square per meter per grams. We develop a technologies, and I'm trying to prove it. It is a common things. I can take the any polymers biochars, natural biochars, and then the formation of those biochars can be utilized for different application, including CO2 sequences in there too. So one of the biochar or one of the materials we prepared is it is giving up to 29% or 29% at 0 degree Celsius, absorbing CO2 is in there too, But then we are also work on the CO2 utilizations. One of the groups who is doing the catalysis, he used the CO2 and hydrogen converting methanol, formic acid, which is the fuels. Methanol is a billion-dollar industries. So she developed a catalyst, she claimed she developed a catalyst that is showing the highest yield in the world reported so far. The trick is how to make that catalyst. In that things fundamental is coming up. Now the CO2 is activation of CO2 is coming in the pictures. COO, how these two oxygen in the similar metals or two different metals are activating. One of the oxygen of CO2 is activating differently from others. At the same time, hydrogen, which is the second part of there, that is also activating with the metals, isn't there too? So learning those and then interacting those. I mean, another thirst area which I am thinking that in periodic table of the elements in there, like you see that elements in there, I see that chemistry, physics or biology, their activity has been well established nowadays. And all their chemistry, physics and biology activities depends upon their oxidation states, valency, because that is a reactivity, right? Well, then I start thinking, okay, is there still unexplored oxidation state of these metals left? How we can see? Then there, for examples, I give the examples in my lectures that gold exists in the gold 1 and 3 oxidation state. Make hundreds of compounds, thousands of compounds known, their chemistry is known, their behavior is known, their conductivity is known, their fluorescence behavior is known. Then we start working on that. Does the gold 2 exist? And what is the behavior of this gold 2? Same thing goes to the iridium, same thing with zirconiums, same thing goes to different metals, platinums. Platinum exists in 2 and 4. We start discovering the platinum 3, platinum 1, platinum 2.5. The literature is bombarding on me. What you're talking about? You are changing the whole periodic table, whole chemistry. Paper is going through, the concept is developing. There's no question at all. Then we start thinking the utilization of that. What I found that platinum, gold 1 and 2, gold 1 and 3, which they are very active towards the oncology, cancer treatment, but the gold 2 is very important. Gold 2 is start interacting with the oxygen molecules. Gold 2 is start reacting with all those drugs molecules which you take. Gold 2 can become a carrier to the cancer tumors over there too. But then I took the biologist in there, medical doctors in there, I do the fun. I do the fun. I play with the disciplines, right? I challenge myself, I challenge my students, I challenge the things, sometimes right, sometimes wrong. But one thing is sure, it is a fun.
Good.
It is a fun.
So one question comes on carbon credits,
Yeah.
which I have not understood so far. What are carbon credits?
I don't know much about it. All I know that they are saying that every industry is allowed to do a certain amounts of carbon, and there are industries which they established, and some things there that suppose a industry said that you're allowed to produce that much of carbon dioxide in the air, and they produce 20% more, then they will be imposed the penalty. But what they can do, those industries which are not producing carbon dioxide at all, they can buy this carbon credit. They can say, okay, we will take some of the carbon dioxide responsibility on us, and then credit the amount of the fine, so that something goes back to them. There is a lot of folk industries, they're not doing anything, they're just taking the carbon credit.
Okay.
They are establishing there too, but they are just taking the carbon credit. I mean, there is a business, remember that business has one very funny things. Business always exists to make money, to make profit. Sometimes ethical. I mean, I can tell you one thing actually, you are there too. There's a 3 definition there. When you talk about the growth of the business, growth is when you convert 50 million to 100 million, 100 million to 500 million, 500 million to 1 billion. Well, that is steady growth, right? When you talk about the progress is there when you see this growth ethically with the norms. That call is progress. You don't have any litigation, you don't have the bad names. You are progressing is there too. And then third terms come is a success. When you also contribute to other things, to the community, some of the profit back to the community from where you're taking there too, that becomes the success. So some business are very successful. Some business are keep growing, right? But growth did not bring you the success. Success is very different, right? Well, you choose. I mean, these are the formulas of the business when the business connect with the different others.
Any other question, or shall we wind? Yes, please.
So, I have 2 questions. First question is that how are you able to, take the higher education or the solutions that were found in labs to the industry, and how do you do that? And secondly, how did you, what motivated you to come into this particular field, and can you share about the progress and
Okay, the first answer is there to that. I usually watch what is going around. So I try to fly You see that sometimes you see in the skies a lot of birds are flying and all their birds are flying in this way. And then you see the eagle is flying opposite, alone above than that. So I watch them and I say, well, she is looking from the distance, she is looking the whole things. While this bird is following to each other and going what are the wrong and right, flew against the trend, right? Okay? Same thing is go. I mean, if you go against the trends, at least you will attract the eyes, right? First thing. Second thing, for example, that's why. Now, for example, nowadays, I mean, when I started my career as a academics, always they say, if you have money, you have research. No money, just go for teaching. Two choice. I came out to very strong backgrounds. I was supervised for Nobel laureates. I Imperial College, extra college, things. I published a lot of top papers in there too. So isn't there. So I always ready to accept the challenge. Guys, I was never wanted to become a researcher. Forget, the reality was there. I was selected for 48 GDOC, Indian Air Force, in 1975 in Dehradun.
I think we can close today's session, and thank you very much once again. Okay.
Sorry, dear.
Thank you. It's fine. Good, nice, very motivating talk.
Well,
Good. That's what actually we wanted.
I try to
At
speak
the
the
back
truth.
end of the day, somebody should come and hammer us with some ideas, good ideas.
Thank
Nice.